All right, we're going to be looking at the second part of our 3.3 worksheet. This will be 3.3b, and this is your homework help video. So I will do the evens, you will take care of the odds. So looking at problem number 16, our job is now to compress these, put them together. So coming over here, we see a subtraction. That's going to tell us to divide. So we will have log base 3 of x over y. I like to put parentheses around because that's a quantity right there. Remember, the first one is what goes on top. The one that's being subtracted goes on the bottom. Looking at the next problem, number 18, one of the first differences we see is this coefficient of 3. That's an exponent. So we're going to put that back up top and make that b to the third. At this point, we again see subtraction, so we want to divide. So we're going to have log base 4 of a over b to the third. And again, that's a quantity, so I like to leave that in parentheses. Looking at problem number 20. In this situation, again, I see exponents, so my job is to first move those up to the top. Now, it's important to realize that that negative in front of the 2 is not like a negative 2. In this sense, we don't move a negative exponent up there. Now, looking at this problem, I would come over here and I'd rewrite it as log base 4 of x to the third. That will be the top one, since that 3 moved up there in the exponent. And then on the bottom, since it's a minus in front, this is going to go on the bottom. I'll have my y squared. And then since there's a plus in front of this 4, that one's actually going to go up on top. So z to the fourth will go over there, making this my final answer. Looking at number 22, a couple different ways to approach this. I'm going to deal with the 2 later. So I'm going to put these together to start. So I will have log base 5 of x over y. Now I know I do still have a 2 in front, so that 2 needs to pop up to the exponent. So this will be the same as log base 5 of x over y squared. Now, another way you could have approached this situation is actually to distribute the 2 in to start. If you were to have done that, you would have gotten 2 log base 5 of x minus 6 log base 5 of y. Now, again, you have coefficients, so move them up to the exponents. And then you would have log base 5 of x. Sorry, it's going to be x over y, right? X is going to have an exponent of 2, and y is going to have an exponent of 6. Now, if you're looking at these things and saying, well, those aren't the same, well, yes, they are. Actually, hold on. Oh, I forgot to put my 3 up here. That's first mistake block. I'll have my 3, and then when I come over here, I actually would distribute that 2 through, and I would get to the same spot. Okay, either approach is valid. Use whichever one you prefer. Looking at this one, I'm going to just do the distribute in early method here. So 1/2 log base x this is just log base 10 if we don't see something. So x minus 1/2 times 2 is going to give us a -1 log base y. And then we're going to have minus 1/2 log base z. Now remember, your coefficients become your exponents, so you're going to move those up. One thing about this -1, we don't even need to put it in there in this situation because the 1 as an exponent doesn't change anything. So coming over here for our final answer, we'll write log of x to the 1/2, because that was the exponent, over y, since that was a minus, it goes on the bottom. Another minus, this is going to go on the bottom, z to the 1/2. Now, anytime you have something that's to the 1/2, that's always the same as saying take the square root. So we could say the log of the square root of x over y square root of z. And this would be our final answer for it. Looking at problem number 26, when we come over here, we're going to approach it the same way. Coefficients go up into the exponents. That needs to be really the first step that you perform. So I'm going to end up with log of a to the 1/2. That's on the top, since that was like my first one. It was the positive. Since the next one is minus, b squared is going to go on the bottom. C squared is going to go on the bottom, since it was also a minus. And then d is going to go on the bottom. Now we can make that a little bit nicer by rewriting a to the 1/2 as the square root of a. So let's do that. So we'll have the log of the square root of a over b squared, c squared, d. And that will be my final condensed form of that. Looking quick at number 28, again, we're going to move the 1/2 to the exponent, the 1/3 goes to the exponent, the 2 goes to the exponent, and the 1/3 also goes to the exponent. So coming over here, I will have log of m to the 1/2 over. Now, all the rest of these are minuses, which means they are going to go on the bottom. N to the 1/3, p to the second, and q to the 1/3. Now, we should rewrite anything with a rational exponent in radical form, so we'll rewrite it as log of the square root of m over, now let's look at this for a second, n to the 1/3 and q to the 1/3. When I rewrite those, that's going to be the cubed root of n and the cubed root of q. And since we have two cubed roots, we can actually put these two things together. So this will be the cubed root of n cubed. And then p to the second is still going to be sitting on the outside, making this my final answer. Two more questions to go very quickly. We're going to use the change of base formula to evaluate these with our calculator. The way we do that is we look at the natural log of 10 and we divide that by the natural log of 1.4. The base is always the one that goes in the bottom. I think that's how I use it to remember. Looking over here, if I evaluate this, natural log of 10 divided by the natural log of 1.4 gives me an answer of 6.84, let's call it 33. Now, here's the nice thing about this. We can actually evaluate this and kind of check this, right? Because what this is really saying is that if I take 1.4 and I raise it to this power, it should be equal to 10. Now, we did chop that exponent up a little bit, so we're going to get really close to 10, but we won't be exactly. So checking our work, 1.4 raised to the 6.8433 power. Oh my gosh, 9.9999. We are so close to 10, it's not even funny. That means we did our work correctly. That's one way to check your answer. Looking at the second problem, change of base formula again. We take the natural log of 2, divide it by the natural log of 5. Natural log of 2, definitely want to close that parenthesis, divided by the natural log of 5 is going to give us 0.43, let's just call it 0.7 when we round up. So again, if you wanted to check, and it's not mandatory that you do check, but on your test, I would recommend it. 43075 to that power, the one we just found, should equal 2. So checking that 5 to the 0.4307, oh my gosh, we are darn close to 2. Ladies and gentlemen, that is it for today for this video. If you have any questions, please do not hesitate to reach out. I am here to help. Have a good day.